Hello, and welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery, and as always, I'm joined by the brilliant Anna.
Hi, Avery, and hello to all our listeners. We have a busy show today, covering everything from a groundbreaking new private space telescope to Russia's only crewed launch pad running into some trouble.
Plus, we've got the James Webb Space Telescope doing what it does best, peering into the heart of our galaxy. And we'll look at some stunning new photos of home. So let's get started. Anna, tell us about this new telescope.
Absolutely. Our first story is a big one, though it comes in a small package. A new space telescope named Mauve, about the size of a mini fridge, just launched successfully aboard a SpaceX transporter mission.
Okay, a mini fridge in space. What makes this one so special?
Well, unlike Hubble or Webb, Mauve is owned by a private company, Blue Sky Space. And this is the key difference. Its data will also be private. Researchers will have to subscribe to get access to the ultraviolet spectra it collects.
A subscription model for astronomical data. That's a fascinating shift.
It really is. The mission was funded by a mix of EU grants and private funding, costing significantly less than comparable NASA missions. It's built on a CubeSat chassis, which is incredibly compact, and will spend 3 years in low Earth orbit observing exoplanets, stellar flares, and monitoring stars.
So why would astronomers pay for this? Is the data that unique?
It's about access. Time on telescopes like Hubble is at an extreme premium, and most proposals get rejected. Mauve offers a dedicated stream of ultraviolet data, which is only accessible from space. For many institutions, an annual subscription could be a more reliable way to get the specific data they need for long-term studies.
That makes sense. So this could be the start of a whole new commercial market for astronomical observation.
Exactly. Blue Sky Space already has another mission, Twinkle, planned for 2027 to study exoplanet atmospheres. With falling launch costs and miniaturization, this could really change how a lot of astronomical research is done.
Incredible. From a new beginning to a potential problem, our next story takes us to the Baikonur Cosmodrome in Kazakhstan. Anna, you have the details on some trouble for Roscosmos.
That's right. Following the successful launch of the Soyuz MS.28 crew to the International Space Station, it seems the launch pad itself sustained some significant damage.
What happened exactly?
During the post-launch inspection, Roscosmos confirmed that a maintenance cabin located in the flame trench at Site 31-6 collapsed. This is a critical piece of hardware needed to prepare rockets for launch.
And this is Russia's only active launch pad for sending cosmonauts to the ISS, right?
That's the crucial part. They used to use the historic Site 1, Gagarin's start, but it was retired in 2020. So since then, all Russian crewed and cargo flights have gone from Site 31. Roscosmos says they have the spare parts and will repair the damage, but some outside estimates suggest it could take up to 2 years.
2 years? That would have a major impact on their ISS operations. There's a Progress resupply mission scheduled for next month.
Indeed. It's unclear at this point if that schedule will hold or if another pad could be adapted. The good news, of course, is that the Soyuz MS-28 crew, including NASA astronaut Chris Williams, arrived at the station safely and are beginning their 8-month stay.
A situation to watch for sure. All right, let's shift our gaze from Earth orbit to the very center of our galaxy. The James Webb Space Telescope has been watching the Milky Way supermassive black hole, Sagittarius A star, and it saw something spectacular.
It did. Astronomers used Webb to observe flares from Sagittarius A star in mid-infrared light for the first time. We've seen these flares in other wavelengths, like near-infrared and radio, but mid-infrared was the missing piece of the puzzle.
Why is seeing it in a different wavelength so important? Does it just look different?
It's about understanding the physics of what's happening. The processes that create these flares don't show up in all wavelengths equally. By observing in mid-infrared, Webb is bridging the gap between what we see in near-infrared and radio waves, giving us a more complete picture of how the flare evolved.
So what did this new view reveal?
Two really cool things. First, they confirmed that a process called synchrotron cooling is happening. This is when high-speed electrons lose energy by emitting radiation, and that's what powers the mid-infrared light we're seeing.
Okay, synchrotron cooling. And the second thing?
This is the big one. Because the speed of that cooling process depends on the strength of the magnetic field, these new observations allow scientists to measure the magnetic field around the black hole more directly and cleanly than ever before. It's a critical parameter for understanding how these cosmic giants are sculpted and how they eject so much energy.
Wow. So we're getting a direct measurement of the magnetic environment right next to a supermassive black hole. That's a huge step.
It is. And the lead researchers emphasized this was only possible because of Webb's MIRI instrument, which can observe in that specific wavelength with incredible sensitivity, something impossible from the ground.
Absolutely incredible. So now that we have this new tool to measure the magnetic field so close to the event horizon, what's the next big question these researchers are trying to answer? Are they looking for something specific in future observations?
The ultimate goal is to understand how Sagittarius A star feeds and grows. These flares are thought to be the crumbs from its meals, gas and stars that get too close. By studying the magnetic field, scientists can build better models of the accretion disk, which is the swirling vortex of matter that feeds the black hole. They want to understand how this magnetic field extracts energy and launches powerful jets of particles, a phenomenon we see in more active supermassive black holes across the universe. Webb's observations are providing the crucial ground truth for those theories.
Another win for Webb. Okay, from one innovative space mission to another, the European Space Agency just launched its first Scout mission. Anna, what is HydroGNSS scouting for?
As the name suggests, it's scouting for water. HydroGNSS consists of two small twin satellites, also launched on that same Transporter 15 rideshare flight we mentioned earlier. Their goal is to improve our understanding of Earth's water cycle.
And how are they doing that? What's the technology?
It's a really clever technique called GNSS reflectometry. Essentially, the satellites listen for signals from navigation systems like GPS and Galileo. They compare the signals they receive directly from the navigation satellites with the signals that have reflected off the Earth's surface.
Right, and the way those signals change after bouncing off the ground tells them something.
Exactly. It reveals valuable information about key parts of the water cycle, such as soil moisture, the freeze-thaw state of the ground, areas of flooding or wetlands, and even the amount of biomass in forests. These are all critical for things like predicting floods, planning agriculture, and understanding carbon cycles.
You mentioned this is a scout mission. What does that mean for ESA?
It's a new approach for them, inspired by the new space philosophy. Scout missions are designed to be fast, agile, and low cost. They go from concept to launch in just 3 years with a lean budget, complementing their larger, more traditional Earth Explorer missions. HydroGNSS is the first of this new family.
That's fantastic. It's great to see agencies embracing faster, more innovative development cycles. Finally, let's bring it back home. NASA's OSIRIS-APEX spacecraft recently swung by Earth and sent back some souvenirs.
It did. Listeners will remember this spacecraft as OSIRIS-REx, the mission that successfully returned a sample from the asteroid Bennu. After dropping off its precious cargo, it was given a new name, OSIRIS-APEX, and a new target, the asteroid Apophis.
And to get there, it needed a little help from home.
That's right. It performed a gravity assist flyby of Earth, using our planet's gravity to slingshot itself on a new course towards Apophis. During this maneuver, it flew just over 2,000 miles above the surface and took some absolutely stunning photos of Earth, showing swirling cloud patterns over blue oceans.
I saw those pictures. They're breathtaking. It also got a shot of the moon, didn't it?
It did. As it was departing, it captured a dramatic image of the Earth and moon in the same frame from about 370,000 miles away. Besides being beautiful, these images confirmed that its cameras are working perfectly ahead of its new mission.
And its target, Apophis, is a particularly interesting asteroid, isn't it?
Very. Apophis will have its own extremely close encounter with Earth on April 13th, 2029, passing closer than many of our satellites. OSIRIS APEX is scheduled to arrive shortly after that pass, making it the first mission to study how an asteroid is physically altered by a planetary encounter. It will orbit Apophis for 18 months, mapping it and even firing its thrusters to stir up surface dust for analysis.
It's amazing that they can get so much more out of one spacecraft. Why is Apophis in particular such a high priority target? Is it just about the close flyby, or is there something special about the asteroid itself?
It's a combination of both. The 2029 flyby is a once-in-a-millennium scientific opportunity to see how Earth's gravity can physically alter an asteroid, potentially triggering asteroid quakes or changing its spin. But Apophis is also an S-type or stony asteroid, which are very common in the inner solar system and are the type most likely to pose an impact hazard. By studying its composition and structure up close, especially after it's been gravitationally stressed, we gain invaluable data for planetary defense models. It's a perfect natural laboratory.
An incredible second act for a history-making spacecraft. Well, that's all the time we have for today. From private telescopes and damaged launch pads to black hole flares and Earth scouting satellites, it's been another busy day in space.
It certainly has. Thanks for tuning in to Astronomy Daily. Be sure to subscribe wherever you get your podcasts so you don't miss an episode.
Until next time, I'm Avery.
And I'm Anna. Keep looking up.